Now that we have our data set, we can proceed over to generate our project. And we're going to create a new project from our data set, and we see that we've generated 9 variables. They've been generated according to a whole selection of default settings, but we can then proceed to customize them as we desire. There are 2 primary methods of customizing your project at this point. First of all, we can impose certain structure on the variables. That is to say, we can compel them to be in relationships to one another. We can also prohibit such relationships from being discovered as part of the learning process, which we'll turn to soon. We can also customize the parameters of the variables. We've got a multinomial distribution, and here we have the parameters governing it. They're actually Dirichlet hyperparameters. We can examine the frequencies of the values as found in the dataset. We can look at pairwise correlation tests. And on the basis of expert knowledge, we can begin to specify custom values for the parameters of our distribution. The default treatment of continuous variables is that we discretize them, and we can govern the discretization algorithms over here. So if we find a discretized variable, here we see that this variable has been divided into 9 intervals. It's been divided using an equinumeric algorithm that attempts to fit as close as possible an equal number of data points into each interval. But there are alternative algorithms, equilength, based on standard deviation in the data set, customized, specifying all the cut points, or k-means algorithms if we want to start getting more sophisticated.